Now imagine, let's say we have these actually two exponential equations, and we are told to actually solve the values of x as well as the y simultaneously. So that is the essence behind the video. We want to discuss how we can be able to solve the exponential equations simultaneously. So in case you know, just have to feel free and pause the video and try to solve, then check over once the actual equation has been solved. So here we go. So in this case we have the first equation, and which is 2 to the power 2x plus y, and which is equal to 3, actually which is equal to, and that should be 8. So now we should have to first of all simplify the actual equation. So how should you have to simplify the equations? So you should have to understand that, let's say if we have a number m, you know this is the same as having it as m to the power 1, because 1 is always neutral whenever it is being presented as the positive power. So what we have there is that we have 2 to the power 2x and plus y, which is equal to 8 to the power 1. That's what is happening there. So we have the exponent, you know, we have an exponent, and also this is an exponent. Now let's think of their actual bases. So we have, in this case we have the base 2, in this case we have the base 3. Now what is the lowest possible, what is the base between, what is the lowest base between actually 2 and 8? So the lowest base is given as 2. Then we should have to think of, is it possible to express 2 to have the base other than 2 itself? You see that it is impossible. Then can we have to break 2, and so that we should have the factors of 2, and such that one of the factors can be expressed in the other base other than 2? You see that it is impossible. For example, if we could have, let's say 20, you know 20 cannot be expressed to have the base other than 20 itself, but it is possible to have, you know, 5 times 4. In this case it is the same as 5 times 2 to the power 2. So this is possible, but now with these two it is impossible. So which means the only thing we should have to decide is to make sure that 8 has the same base as 2. So in this case we should have to express 8 to have the same base as 2. So in this case we have it as 2 to the power 2x and plus y, which is equal to 2 to the power 3, because 2 to the power 3 is the same as actually 8. So in case you may need to understand more about how we are making up all these things, just have to refer to the video, you know, we discussed about the solving actually equations that involves solving the exponential equations. By the way, this is just a part of application, because our interest is just have to solve exponential equations, that our interest just have to solve the actually exponential equations simultaneously. But we have also another video we discussed about solving exponential equations, where you come across all these things. And also don't miss it out on the laws of indices. That's the video we discussed before all these things. So make sure that you are in the same line. And these videos can be actually are found on the actually a Facebook page, a YouTube channel, you know, TikTok, as well as the Instagram. You come across all these things, you don't need to miss. So in this case we have the bases being the same, so just have to equate the powers, because according to the principles behind, if we have x to the power m and which is equal to x to the power n, so since the bases are the same, then we just have to equate the powers. So have m is equal to n. You know, likewise if we have x to the power m and which is equal to, let's say, and that should be y to the power m. Now since the powers are the same, then just have to equate the bases. So have x is equal to y. So don't forget this. So how should you have to proceed that on? So since the bases are the same, then just have to equate the powers. So have 2x, you know, plus y is equal to 3. Now this is regarded as equation number 1. then we should have to go for the second actually equation, which is 3 to the power x minus y, which is equal to 1. So in this case it is the same as 1 to the power 1. Now we have, in this case we have base 3, and the base 3 cannot be expressed to have another base other than 3 itself, and the only thing we should have to decide is to express 1 to have the same base as that of 3. Now how should you have to ensure that? So keep in mind that any number to the power 0 is the same as 1. So in this case, since the base of interest it is base 3, it means we'll have to think of having, 3 to the power 0 is the same as 1. So in this case we'll have 3 to the power x minus y, which is equal to 3 to the power 0. So since the bases are the same, just have to equate the powers. So what would be that one? So in this case we'll have it as, x minus y, which is equal to 0. Now this is equation number 2. Now we can be able to solve actually for those two equations simultaneously. Now we are on the verge where we can be able to solve those, as fast as possible. Make sure that you are well actually oriented with the way we solve simultaneous equations, either substitution method, elimination method, and even that of the graph method where it is necessary to. So what method should you use here? So the simplest method we can have to decide is to use the elimination method, since we have the same terms here. We have a single y and also the single y here. So in this case, let me present them properly here. Have it as 2x plus y, which is equal to 3, and we have x minus y which is equal to 0. So since we have here y and y, let's think of eliminating y first. So just have to add the two equations, since we have here positive and here is negative. So those actually those terms will go. In other words, that variable go. So in this case we'll have 2x plus x, that is 3x. And I'll have here 0, and which is equal to 3 plus 0, that is a 3. So in this case we'll have x being given as 3. Then I will substitute x into either one of these two equations. So let's think of substituting into, let's say, equation 1, and that is for x is equal to 3. So which means in equation 1, where there is x, we're going to substitute with 3. Then we'll be able to solve y. So now have it as 2 times 3 plus y is equal to 3. So have 6 plus y, which is equal to 3. So y will be given as 3 minus 6, that is the same as negative 3. So that is the solution for y. So in this case we have managed to solve for x as well as y. So x is equal to 3 and y is given as the negative 6. So those are the solutions you should have to get. Now but let's see if we have something like this, and see how we can make it up. Let's say we have something like this. Let's say we have 5, let's say we have 5. That should be, let's think of having 3. Let's say we have 3 to the power 5x, let's say minus 2y, now which is equal to, we should have it as 2 therefore. And we have the another equation, which is 3 to the power 2x, and the minus y, which is equal to, should be 3 in this case. So how should we have to solve those two equations simultaneously? So let's just start one by one by simplifying them. So in this case we have 3 to the power 5x minus 2y, which is equal to 2, 3, 4. So in this case the lowest actually base is 3. So there is no any other way 3 can be expressed to have another base other than 3 itself. Therefore our humble duty is to express 2, 34 to have the base 3. But how should we reach up to that point? So let's think of using this technique. So we have 234, and we'll have to divide by 3 all over. So with a calculator, what is 234? Divide by 3. So we have it as 78. And also have 3, divide by, should be 78 divided by 3. That is, we have it as, by the way, we should have this as 243. And that should be 243. So 243, should be that. And also here we should have it as 243. And in that case, we should have it as 243 as well. So 3 into 243, we have it as 81. So it should be something like that. So we'll have it as 81. And 81 divided by 3, and that is 27. And 3 into 27, we have it as 9. And 3 into 9, we have it as 3. And 3 into 3, we have it as 1. So in this case, we have, we have 3 to the power 5x minus 2y. It is the same as 3 to the power. So we have 1, 2, 3, 4, 5. So we have to the power 5. Now since the bases are the same, we just have to equate the powers. We'll have 5x minus 2y, which is equal to 5. So this is equation number 1. And we should also do the same with another equation, in order to have the simplified version of the equation. So in this case, we have the second equation, which is 3 to the power 2x, minus y, and which is the same as 3. So just having this 3 is the same as 3 to the power 1. So since the bases are the same, just have to equate the power. So have 2x minus y, which is equal to 1. So this is equation number 2. So from that point, you can be able to solve the two equations simultaneously, either substitution method or elimination method. So whatever the method you feel like you can use. So keep that in mind. And how about, let's say, if we have the following actually cases. Let's say we have 5 to the power x, and that should be times, let's say, 5 to the power 2y, and which is equal to, let's say, 25. And now we have the another equation, which is 3 to the power 2x, and divide by, should be 3 to the power y, which is equal to 81. So how do you think this one can be actually solved? And we should also try to have this. And by the way, these questions should be done by yourself. Let's say we have 3 to the power, let's say, 2x, and minus y, which is equal to 27. Let's say we have the another equation, which is 4 to the power x, and which is divided by, we should have it as 16 to the power y, which is equal to 1. So how do you think we can have that? So try to see how best you can handle that one. So this is how you should have to understand about the solving exponential equations simultaneously.